So this is like your 8.3 normal sampling and modeling. They've given us a question. Has to do with resistance of ohms. And what's the important part is that we have a mean of 15.08, standard deviation of 1.52. And they want to know the probability of being between 13.8 and 16.2. So let's kind of try to draw this a little. Our mean is going to fall in the middle of our normally distributed bell curve. So this is our 15.8. Well, one deviation to the right and one deviation to the left will be essentially this much would be adding 1.52, and over here would be subtracting by 1.52, right? So when we do those, and these will again give us ideas of where our percentages should be around. 15.08 plus 1.52, 16.6. Okay, so that's this way, 16.6 with one deviation that way, and 15.08 minus 0.52, 13.56. So 13.56. Okay, so that's one deviation both ways. Now we know that within this amount is how much? From here to here, how much of the data or how much of the area of this bell curve is there? Yeah, that's 68%. Well, it just so turns out that we're looking for 13.8, and if we look at these values, that's going to be a little to the right of this, right? And 16.2 is a little to the left of this. We're not exactly sure where, but we've estimated on our graph this will be our 13.8, and this will be our 16.2. So in other words, we're of a smaller amount. So we know we're going to be less than 68%, whatever we are, okay? Because we're taking up an area that's less than that. But what we want to do is you actually want to convert this entire bell curve into z-scores, okay? We want to convert this all into our z-scores here. And when we do that, we're going to take our data, subtract it by the mean, and all above the variance, right? And that'll give us our z-score amount. So first we do our 13.8 minus 15.08.
It's 13.56, just because it'll come out at a different answer. You wrote 13.58 plus 13.56.
What is?
Our
This?
first point. Yeah.
Oh, you mean the variance?
No, never mind.
Well, let me check the question then. By that, I made a small error here. That should be a 6, but more importantly, this is still the same. There's no change here. So this is equal to, and then our variance being 1.52. So when we do this, take our calculator. 13.8 subtract 15.08 is equal to divided by 1.52. 0.842. So negative 0.842. Okay. Is that right? Okay. So we're looking for data that is essentially to the left of this. We're looking for the amount of area under that. So in other words, let's say we put this as a z-score, right? If we were to draw this as a z-score, oops, let's use this full one here. A bell curve talking specifically about z-scores. Okay, I know it's not perfect. Think of this being the amount of area. Okay, this is the probability that our x is less than this amount. Okay, or our z-score, when we go to break it up, is actually going to be the probability of that z is less than that amount. Right? Yeah. And z is less than that amount. We're going to find out what that amount actually is. So this should be a z here. Okay? This gave us our z-score. It shouldn't have been an x there. So probably that z is less than that. We're going to find out that amount by looking on our chart in order to solve this. But what I want you to realize is think of it like we're going less than a new mean here. So let's take a look at our chart just so we can get our amount here. Okay, so we just found our amount when we checked out our z-scores. Now, the way we can also think about this, if when they change this, as this being 0 deviations from the mean, this being 1 deviation from the mean, this being supposed to be symmetrical, 1 deviation from the mean. Well, when we go back negative 0.0842, right? Think of this as negative 1 deviation. This is positive 1 deviation. You know, this would be positive 2 deviations. This would be negative 2 deviations. Okay? Well, our z-score being less than negative 0.842. Well, in terms of a negative, that actually falls a little to the right of this, right?
Yeah.
Negative 0.842. And if we take a little bit of a greater look at this, that makes sense,
yeah, it's the
right?
same.
Because our 13.8 was a little to the right of our deviation, and our deviation were a little to the right of it. That's what that amount is referring to.
Okay.
And remember, we need to find the area less than that. Well, we just did. That's the area less than that. And we just figured that out, so we know we'll do this in blue instead. That's the amount of area under here.
Okay.
So now we have to do the same thing with 16.2. We'll zoom in and, actually, I think we can do it up here. I'm just going to do it on the side in blue. We have 16.6, subtract our 15.08, all divided by 5.2. And this is going to give us our z-score amount, okay? So we'll put that in our calculator. 16.6 minus 15.08 divided by 2. Oh, sorry. 16.6 is our variance, hence why we found 1 deviation. We're supposed to be using 16.2. That's my mistake. 16.2 is what we should use. It makes sense. 16.6 is 1 variance, which means it would have fell perfectly here. But that's not the number we're looking for. So let's try that again. 16.2. Subtract 15.08. That's better. Divided by 0.52. And again, a little less than 1. 0.736, right? So 0.736. In other words, a little to the left of 1 full deviation. That represents our 0.7. Whoops. And we'll zoom in for that part. That zoom in. There you go. 0.736. Is that what we said?
Yeah.
Okay. So that's this amount. Now the problem is when we go to look this up as a z-score, and do you want to quickly look that up for me? 0.736. They're going to give us an amount. So the probability
0.960, right?
is equal to, sorry, 0.
Oh wait, 0.7. It's up here. 0, 1, 2, 3, 4, 5. I'm looking for 3, right?
7.36. Yeah, so 7.3 on your z-scores.
Okay, 0.6. 7673.
7673. Okay. Now what that has done is that's a probability that z is less than this amount. In other words, the probability that we are less than this.
Okay.
But for our question, if you recall, we're looking for the probability in between. So we need to find out what's greater than this. So in order to find out the amount greater than this, we have to take 1 and subtract this number by it.
Okay.
Okay? So when we go to do that, 1 subtract 0.73673 is equal to
0.2327.
oh, 0.2327?
Yeah.
Great. Okay, so in other words, that is the amount to the right of this. Great. So we have those two. That will now help us find what's our amount in between these two. We're going to take these amounts, this one, and the amount less than it, which was this guy here, and we're going to subtract the two to find out what is our chance of getting between those two amounts. So, okay, so since we have those two amounts, what we need to do now is the probability of x being between 138 and 162, or sorry, 13.8 and 16.2. Because listen, we have these two amounts. This is a certain amount, and this is a certain amount. Well, the entire area here is 1, so we're going to subtract this and this from 1 to find out the probability or the area that's left untouched. So what we'll do is we'll take 1 and we subtract our z-score 0.2327, and we subtract our original one of 0.2005. And when we type that in our calculator, I just did, we're going to get 0.5668. 0.5668. So in other words, 56.6%, which makes sense because if you look way back up here, remember, we knew we were going to be less than 68%, but because of where these bars are, not much less than 68%. So 56% is a logical logical probability of going in between those two.